The question 5 is to find the inflection points in the given questions. This can be done by double derivative. Here we have an equation. All you need to do is double derivative. F dash, you should start with single derivative, then you can go to double. This is f prime basically. F prime of x is 3x squared minus 3 times 2 times 3 is 6x plus 4. This will give you the critical numbers, the increasing, decreasing, but we need double derivative. So f double dash of x would give us 6x minus 6. Equate double derivative of 0. Then we get the inflection point. It will be 6x equals positive 6. This 6 becomes minus 6 becomes positive and it goes to the other side. I have written 6x first. X will be 1. This is the inflection point. Now, when the inflection point is just 1, here in such cases, don't go to do a complicated method or anything. It's very easy. This is it. And now you can just do the number line and find it out if you want to find concaving up and down. But if it's just the inflection point, this is it. This is the answer. But here now, 1 is the inflection point. So let me take a value less than 1. If I take a value less than 1, that will be 0. And over here, I'll take more than 1, say 2. Substitute it back in the double derived equation over here. If you put 6 as x as 0, you will get negative 6, so minus. And here if you put 2, it will be 12 minus 6, it's positive 6 plus. It's very easy. Now here it will concave downwards, it will concave upwards. This is the answer. This is it. Please remember, if you just get one inflection point, or if the equation is a simple one, x cube, when we derive it, we will double derive it, we'll just get a linear term. To this, it's very, very simple. But let's look into a complicated problem. That's the answer here. I'll just write it out properly. Inflection point is x is equal to 1. It's concaving downwards from minus infinity till 1 and concaving upwards from 1 till infinity. So that is the answers over here. So you can see the solution. Here f double derivative is greater than 0 at, sorry, this is increasing, decreasing. This one, concaving down, we had got the same, right? Down from minus infinity to 1 and up from 1 to infinity. And this is the inflection point. Now, if you have, say, x to the power 4 or a complicated equation, let's try to do a calculator method as well. But the first thing is you can just double derive it and get the answer. So let me just try it out. F dash of x is equal to 4x cubed minus 12x plus 2. And then when you double derive it over here, it will be 12x squared minus 12. This is it. Now we can put it in the calculator, mod 5, 3 and get the answers. But since 12 and 12 is common, it's going to be x is equal to plus or minus 1 by factoring. These are the inflection points. Now, you can do minus 1 plus 1 and find the points and do it out. The entire lesson explanation is done on this. But now I will suggest you a shortcut method because it's MCQ part. Let's take our calculators. Let's go to mod 7, that gives us the table. Let's type this equation out. Alpha x to the power 4 minus 6 alpha x squared plus 2x plus 3. And now press equal to. If you have your latest model of calculator, then you will get this option. Just ignore it. Press equal to. Now the starting point, here we have minus 1, right? Let's take some 2 to 3 values less than minus 1. So what I would suggest is you can start like minus 3 or minus 4. Okay, start from the least value, some values behind it. And ending, 1 is the maximum point. Depending on the options. Now, if your options are, say, 3, I would suggest to go with 5, okay? Now, depending on all the 4 options. Then what you do is, you can press, say I will consider over here 4. For the step, if you have 0.5, it will give you more detailed data in the sense, from 4, 3.5, 2.5, all these values data will be given. But if you put step 1, the x values will be from 4, 3, 2, 1, that's it, as a whole. But the problem is if I put minus 0.5, it may not give me the answer, it will tell insufficient data. Okay, here I got it, but sometimes you might get an error answer. So then just put step 1 because there is too many values to calculate when it's 0.5. That's why. Now here, let's look into the values. You don't need to graph it, but if you graph it, you'll get a better understanding. For this one, I'll just graph it. Otherwise, you can just look into this data and understand. So let's just draw a coordinate grid. Here we have started from -4, say -3, -2, -1, 0. Same thing, 1, 2, 3, 4. Okay. What is the value here? It's 155, which is a big value somewhere over here. Then it's reducing to 72. We can see it's reducing. Once only it fell down till it's reducing considerably over here. And then if you look at the other values, again it's reduced, now increased. See, it reduced from here, it dropped considerably, and then it was over here. Then what happened? From -9, it's increasing, right? If it was lesser than -9, it should have been -10 or something, but it's coming up here. And if you see the other values, now this is the important point. That's somewhere over there, critical numbers will be there. It's increasing. Can you see it's increasing again? Till 0, it is increasing. So what I can do is from here, I know something's happening, increasing, but again at 0.5, it started decreasing. So here I started decreasing again, and now it's becoming more less until 2 value. See, again it's decreasing, decreasing, but now at 2, it starts increasing again. 2.5, it's increasing. So this is the graph from this table. Now from this calculator method, you get a brief understanding of how the graph is. So even if you didn't have this inflection points, from here, see if I just join these points, it's something like this, and it's going up over here, and it's something over here. Now x to the power 4, yes, this graph corresponds to it. You should know the basic understanding of the graphs. If it is x squared, it's going to be something like this, a parabola. X3, it will be just like this. If it is x4, it's generally a W shape. X5 would be having more distinctions over here. So that is the thing. Now, with that basic knowledge, you can easily predict where is the maximum minimum from this information on the graph. Here is maximum 0, minimum would be at -2, minimum at again +2, I believe. I did not plot the right side properly. But then the inflection point will be somewhere in the middle over here. So this is the minimum, this is the maximum, right? From here until over here, it is concaving upwards. And -1 is an inflection point. Then from here to here, it will concave downwards. This is also an inflection point. Then over here, from here, it's going upwards, concaving up. So we have from -infinity till -1, and from 1 till infinity, concaving upwards, concave up. Whereas from -1 to 1, it is concaving down. This is the understanding of the concavity. Inflection points would be -1 and 1. Now, how would you understand if you have not done this derivative test? You have 4 options. From this graph, you can predict, because the options won't be exactly the same. They won't give you 1, 1.2 or something like that. The options might be, -infinity till 5. Now, is there 5 over here anywhere? No. Is there 3 over here? No. 2 is the maximum minimum point. That's also no. After 2 you must have, and below 0, right? So its most reasonable answer would be -1. Whichever is closer to -1, that is the answer if -1 is not given. So that's how we can easily predict the answers. This is another shortcut method. Or you can just go with the traditional method of double deriving, making the number line and finding out. It's up to you to choose. And this particular graphing can be done for every problem, even over here. I'll just show you. You can go to more 7 and type this out. Alpha x plus 1 divided by alpha x. Sorry, I should go down over here, and now alpha x. And here, see, it's better to have an understanding of the options. So then you can easily start at a really nice point. Now I'll just give -5, and I'll give 5, and I'll give the step. I think so I'll get an error if I put step of 0.5. See, it's not allowing me because it's too many values to compute. So what I'll do is I'll calculate start at minus pi, end at minus pi, I'll do it at 1. This gave me the answer. 1 generally gives you for about 10 values. Now over here, what's happening? The graph is minus 5.2. It's increasing, and it got an error. See, over here, it increased. Then, yeah, it's still increasing, but then there's an error. Why? Because if you know the graph, this is undefined. At 0, it's undefined over here. And then what is the next thing? Over here, it is increasing. Okay, it's going. So I know that from this graph, over here at 0, it is undefined. But here it is something like this, and here it is something like this, right? So where is it? Where is the critical number? The undefined point is the critical number because we got an error at 0. So critical number will be 0, and also point of inflection is also 0 over here. Why? Because over there it is basically undefined, right? Undefined points or points which make it 0. So that's one thing. And one more thing would be concaving. See, concaving up where? From the basic understanding of graph, I can easily tell it's concaving up from 0 to infinity, and from minus infinity till 0 it is concaving down. So that's given over here, concaving up and down. We're not solving for increasing and decreasing, but here increasing and decreasing also we got the values. They were increasing from minus infinity to 0, right? See, it went up, increased, and then 0 was error. So this is how we can easily predict from this graph. You can easily look into the options. I know 0 must be the critical number or the inflection number. Okay, 0 is there. And till 0, it is going something like this, right? So I can tell this is what's happening. Over here also I can tell this is what's happening. So this is how we can predict the answers if you know the basic understanding of graph. Because it's rational, I know the graph is similar to this. So you can try other graphs as well and easily find it out. And here, please do try them. Even for cosine, sine, you can easily do it by graph. Let's do this one. I've typed this equation in the table. Now it is just sine alpha x minus cos x. Now here I will leave it in degrees. I'm not going to change in radians. Why? Because the starting and the ending point, it's better to understand in degrees. If you know the sine or the cosine graph, what generally happens? Sorry for that line. It's something, imagine it's 0. Sine graph will start at 0. It goes up. Now this will be 90, right? And then we have again 180, 270, 360. It starts repeating. It comes over here at 360 degrees. And generally we will denote these in terms of 0, 45, 135. If you know this basic trigonometry, 45 degree would be generally a jump. So here in this case as well, let's take the jump of 45 degrees. But let's not start at just 0. Let's take something little before as well. I would generally suggest you to take minus 180 till 360. Minus 180 degrees, minus pi that is, until positive 360. And let's jump the step, be 45 degrees. So every 45 degrees I'm getting values. Now if you plot this out, see like this only, this is a sine graph, but now this graph we can easily plot it out. If you want, you can just plot the points. Minus 180 is 1, then it's 0. It's decreasing here. You can see it's decreasing, and over here it started increasing at minus 45. So it decreased, some minus 45 is just over here, right? It decreased until negative 1 point something like this, and then it increased at minus 1. Sorry, at 0 it became minus 1. So that means it started increasing over here. Somewhere in the middle of this it increased, and then it went up again. It will go, and obviously something happens like this. We know that's the graph. So if you see, it's increasing, and then it decreased at what point? 180. Okay, I randomly did it. I didn't know this, but it seems that it was increasing until 90, and 180 degrees it started dipping down. So now from this basic understanding, where do you think would be the inflection point? We know over here it is concaving up, right? This part is concaving up. Then it's down. Again, it will repeat because over here this is sine, it keeps on repeating. Now this would be from 180 till 45, in middle of that. It's not 90, it'll be somewhere 50s or something like that, right? Here we know it's pi by 4. Pi by 4 is 45 degrees. For yeah, 45 degrees is reasonable. 45 degrees is the inflection point. Okay, so inflection point is 45. I'll tell you what is this k pi. This keeps on repeating every pi term. It just keeps on repeating. See, again it changes. This is the inflection point over here after pi. Again you can see that from here, again every now and then, every the 180 degrees, it keeps on repeating, right? That's the reason. Now, from this graph, you can easily predict which is the correct inflection point. Four options will be given. Choose the correct one because it's closest to 45 degrees. So this is my correct answer. Now let us think about where it's concaving up and down. Now, since this is the inflection point, left of this, okay, must be concaving downwards, and right of this must be concaving upwards. We can see from here exactly over here it's concaving downwards. This is the concaving downward part, but I have not done the graphing properly, but I can tell for sure from 45 degrees until this is, I'm not sure over here, let's just check. Looking at the points, you can easily tell it. See, it's increasing, then it's coming down. Okay, it should be somewhere over here. It's 225, I can say. Okay, it's around 225 because it's at 0. This is concaving down. It keeps on repeating. Now again, after one point over here, this 0 to next 0, again it will be concaving down. You can keep on writing it. So you can see this three dots, right? It keeps on going. You don't need to put, only one is enough. What about concaving upwards? You can go behind as well. So the last point will be 45, and from here, if you just do the difference, or you can see this graphing over here, you can just keep on going by. It's around negative 135. So that is the thing. Over here they have not used negative, but you can, it's up to you, but they have taken this to this, okay, concaving up from here to here. It's up to you. Now that will be 225 to the next point. After 225, where is it? It'll be about 400 and something like that. So that is the answers. Okay, so concaving up, down, once you get the understanding of graph, but please make sure you draw a better graph, like a proper little accurate. See, there are no many points, you can do a accurate graph, so once you do the accurate graph, make sure you can easily look into this graph and find out where it's inflecting up or down, concaving up and down, or the inflection points. So that's how we can solve all these problems just by graphing. Okay, or you can use the derivative tests and also do this out. Please solve all the problems by yourselves and then go through these answers over here. They're all worked out. I remember this with one of my students. It was much easier to do the table method and find the answers rather than double deriving it, because when you double derive it takes long time. It's just that you'll save a lot of time. That's the most important thing. And then you can easily tell where it's concaving up and down. So that's how we solve this topic. Here, please be careful when you're graphing. See, many of you may do the table but not graph it properly if you're doing the shortcut method. So graph an accurate, not very accurate, but at least an understandable graph, and then you can easily find out the inflection point, concaving, and everything.